Welcome to Lesson 5. This will be our last graphing and Algebra A video in our 5-part series that I've posted here. For Lesson 5, we're working on solving systems of equations. So let's just get right into what that means. First, we are working, there we go. We're working with the different methods of solutions, and you've got 3 different methods. The first is the graphing method. It's the least accurate in my opinion, but you do need to kind of understand how it works. You will be asked to do it, but that's not the most common one. Number 2, the substitution method, is a lot of algebra that you know exactly how to do. And number 3, elimination method, just deals with multiplying and subtracting. So let's just get right into it. The first one we're going to work with is the graphing method. Essentially, all this means is you're going to graph 2 lines at the same time. These can be inequalities or equations. So in this particular example, let's do an equation. Now hopefully at this point, y equals mx plus b is right on top of your mind when you think about graphing. So to put this into slope-intercept format, it's going to be y equals negative 2x plus 1. Let's go ahead and graph that line. Remember, first, you graph your y-intercept, you graph b, which is 1. Your slope is negative 2 over 1, meaning down 2, right 1 to get to your next point. That'll be here. Down 2, right 1 will be here. Alright, so to graph this, that's all you've got to do for line 1. I'm going to go ahead and put the arrows in, and we're done. Switch over to blue, do line 2. Put this in slope-intercept form. I'm going to take 3x away from both sides. I have negative y equals negative 3x plus 9. I have to get rid of that negative in front of that y, so I get y equals 3x minus 9. Now to graph this, y-intercept first. So 2, 4, 6, 8, 9. Your slope is a positive 3, meaning up 3, right 1. So 1, 2, 3, 1, 1, 2, 3, 1. And you see right there you're going to have a point of overlap. And that's exactly what we're looking for. And I'll explain what that means here. Alright, now that I've got that graphed, get that highlighted. Right here, the overlap is exactly what I'm looking for, because that solves the system of those 2 equations. And here's how it does that. This point, if I count over, that looks like 2, negative 1, 2, 3. That's my xy pair where these 2 lines meet. What that means is that is the one point that should make both of these equations true. Let's test that. On the first equation, let me erase some stuff. Got too much going on here. You know how to graph them. I can erase all of this. First equation, if we are testing the point that we found, 2, negative 3 on both these lines, this first one would be 2 times 2, 2x, plus y, that would be minus 3, equals 1. 2 times 2 is 4, and 4 minus 3 is 1. That tests. Down here, you're going to have 3 times 2 minus negative 3 equals 9. Now 3 times 2 is 6. 2 negatives make a positive, and 6 plus 3 is 9. That's true also. So where your 2 lines overlap in the graphing method will give you the solution that makes both of these equations true at the same time. So your solution of this is 2, negative 3. That's your ordered pair, and that's how you answer these. That you've just solved the system by graphing. Now, a couple of different things that I've seen. If you get the exact same line on both of these, if you have the same line, what you're going to have is an infinite number of solutions. So you have all real numbers or infinite solutions as an answer. But that's only if you have you have the exact same line twice. Maybe just one is in a different format. If you're in Algebra 1, you probably won't get an opportunity to see that. If you're in Algebra A, you'll see that come to life as we get into Chapter 4. Right? All right, page down. The next thing is substitution method. Now be careful that you are trying to pick up exactly what you're doing with each of these methods. There's a lot more practice in your book when it comes to using all these. The substitution method, if it says use that, you must use that method when it comes to a placement test. What you're going to do is solve one of the equations for a variable. I'm going to solve it for x or y. This is easy prey, and the reason I say that is y is positive. So if I want to solve for y, then I know it's negative 2x plus 1. That's a simple solution. Then put that y solution in the other equation. So instead of having a y equals this, I'm going to replace that y with this. So here's what that looks like. Once I've converted this over, I'm going to put 3x minus, and in place of y, I'm going to put y, negative 2x plus 1 equals 9. Solve for x. So that's 3x. Don't forget right here I need to distribute this negative to both these terms inside parentheses. 3x plus 2x minus 1 equals 9. Let's go ahead and combine 3x plus 2x. Get 5x equals 10. Divide both sides by 5. I'm going to get x is 2. Now I need to solve for y. I can do that two different ways. I already have up here that y equals negative 2x plus 1. Or I can put in my value of x equals 2, into either one of these equations. It's up to you what makes sense. It's going through the process and getting used to it. So if I want to put y equals negative 2x plus 1, I just solved x is 2. So that means negative 4 plus 1, which equals negative 3. So I have y equals negative 3. If I had decided to use, say, 3x minus y equals 9, then I could have taken this x equals 2 and made that 6 minus y equals 9. And of course, I would need y to be negative 3, so it works regardless. So if I want to solve this system by substitution, I have my x is 2, and down here I have my y is negative 3, and I'm done. So it's the method that you're using, not the answer that you get, is what makes this either graphing or substitution. Notice right here I got 2 negative 3, but I got it in an entirely different fashion than what I got this 2 negative 3, but it was the same equations. Right? Again, you need to consult your book for more examples of those. Algebra A, guys, you're going to do this a ton in Chapter 4. But Algebra 1, you're going to need a little extra practice to make sure you understand what's happening there. And I'll supply that in class. All right, finally, the elimination method. I'm still working with the exact same equations. I've not changed anything there. So my answer will be 2 negative 3. Now let me show you how to get there. For elimination method, what you're going to do is you're either going to add or subtract this entire equation from the other equation. Sometimes this works out to where you don't have to change anything, but I'm going to do this two different ways. We get an idea of kind of what you might end up seeing. Way 1, I'm not going to change anything about these two equations. One of them is 2x plus y equals 1, and the other one is 3x minus y equals 9. Since I have a positive y and a minus y, What I can do is add these equations together. Since they're opposing signs, they're going to cancel out. I won't have any y's. Those are gone. So 2x plus 3x gives me 5x. I don't have any y's left. 1 plus 9 is 10. Divide both sides by 5, I get x is 2. Now, to go ahead and solve for y, I can plug into either one of these original equations up here. I can plug it into 2x plus y equals 1. That's the first one. So bring that 2 over. It means 2 times 2. So 4 plus y equals 1. If I take 4 away from both sides, I get y equals negative 3. And there's my 2 negative 3 up here as my solution. That's one way. That's solving for y first. So I want to do x first. What I would want to do there, I want to cancel x. I want to cancel x and solve for y first. Excuse me. I want to make these x's with the same coefficient, meaning I need to multiply this entire equation by 3 and this entire equation by 2, and here's why. The first equation will turn into 6x plus 3y equals 3. The second equation will turn into 6x minus 2y equals 18. I'm going to distribute that 2 to each term in my equation. Now I have to determine whether I want to add or subtract that equation. In this case, I want to subtract the equation, because if I added them, I wouldn't eliminate x. I would have 12x, and I'd still have a y, and it wouldn't do me any good. My goal is to get rid of one of the variables. When I subtract that, I'm going to have to subtract everything. I can't just subtract one thing. So I have 6x minus 6x. There are no x's. Those are gone. Now I have over here, my next column is 3y minus negative 2y. Be careful on your double signs there, because that equals 5y. And I have 3 minus 18, which is negative 15. When I divide both sides by 5, what I get is y equals negative 3. Of course, we already knew it should equal negative 3. It's just validating it. Now I have all sorts of options of how to solve for x. I can plug y equals negative 3 in here to get negative 9, here to get plus 6, or I can use either one of the original equations that we started off with before we transformed it into way 2. Since y is negative, I think I'll put it into 3x minus y equals 9. When I put a negative in there, that turns into 3x plus 3 equals 9. Take 3 away from both sides, I get 3x equals 6. And I get x equals 2. And there's my solution to negative 3 once again. Alright, so again, right back to here. We got the same thing 3 different ways. Through elimination, either by eliminating my x's or by eliminating my y's. Then before we did elimination, we did substitution, which is solving for y and then plugging that y in place of that y. Before that, we did solution by graphing. And solution by graphing meant we graphed each line independently, tried to find a point it overlapped. The weakness of the graphing method is if it overlaps somewhere not on an intersection to where you can read the point. Say it's a fraction, it falls somewhere in the middle. That's the weakness of the graphing method. Okay, so there's your 3 methods of solving a system of equations. Now you also have systems of inequalities. Let's just quickly cover that. I don't want to spend much time on it because it's so similar to what you already know how to do. But let's go ahead and get the graphing of this set up. I'm going to have 2 dashed lines because we don't have equality symbols underneath the inequalities. I do want to go ahead and put these in slope-intercept form though. So let's move 3x over to the right side. And I'll eliminate it from there. So I get 2y less than negative 3x plus 6 divided by 2 on both sides to solve for y. And I get y is less than negative 3 over 2x plus 3. Let's get that graphed. And negative 3 over 2 means down 3 over 2. Down 3 more over 2 more. And remember I said that would be a dashed line. So let's put that in. Right, there's line 1. Alright, inequality number 2. I'm going to take 2x away from both sides. And I have negative 5y is greater than negative 2x plus 10. Now, what do I need to remember to do if I'm divided by negative 5? Let's reverse my inequality symbols. Anytime I multiply or divide by a negative number. My slope here is 2/5 positive. My y-intercept would be negative 2. 10 divided by negative 5. So let's put negative 2 in there for my y-intercept. Go up to right 5. Up to 2, 4, 5 again. And that's also going to be a dashed line. Yeah, there we are. Alright, so here's my issue. If I'm graphing, I am not sure that that meets directly at 3, negative 1. I know it's really close, but with the graphing method, if I'm just a hair off, I'm not going to know for sure. I just know it's close. Now I can go ahead and come over here and put 3, negative 1 in, but I'm not 100% certain yet. So if I put a 3 in, it's going to be 6. If I put negative 1 in, it's going to be 6 plus 5. And I know 6 plus 5 is greater than 10. I know that. It just doesn't help me know that that's correct. All right. Now, don't forget also, we need to talk about shading a little bit. Right here, I've got y is less than. Now, this is my 2/5 slope line right here. And if y is less than, it means I need to shade down from where that inequality crosses the y-axis. Let's get that shaded in. Now I want to switch over to my green highlighter for this line right here. It's also y is less than. So here's where y met. If y is less than, I've got a graph underneath. Now the system of equations, here's where it's going to look a little different for you. When you're graphing systems of inequalities instead of equations, what you're looking at is overlap of this filled-in spot. Now hopefully you can tell on here where the two overlap. And you have to be kind of creative on your own papers, because all of that looks exactly the same to me, and that's not working out too well. So here, I'm doing this at a lack of options. Here is where those two lines overlap. And don't ever make this black. What you want to do is just shade that in to where it's obvious of which is which. So it's definitely not my preference of how to do this. But there is where the two groups of inequalities intersect. So all of the points within these areas right here, that's in dark black, satisfy these two groups of inequalities. So when we're worried about test points and worried about where the lines overlap, it's not really necessary to worry about putting those in for x and y like we did before. It's kind of what I'm trying to show out of that. All right. Let's see. All right. So on graphing, see where we're at. Now let's do the same thing by substituting when it comes to systems of inequalities. Now substitution, remember what you're doing here is you're solving one of these for either x or y. And there's not one that's more obvious than the other one, so sometimes these get interesting. We can convert this over to y equals. So what that means, let's move that negative 3x over just like we did from the other screen we were graphing. It'd be 2y equals negative 3x plus 6. Divide both sides by 2, and I'm going to get y equals negative 3 over 2x plus 3. Now I'm going to put that y in place of this y. And here's where it can get fun. So I'm going to have 2x minus 5 times, and here's what y equals right here. Negative 3 halves x plus 3 is greater than 10. Now solving this is usually where people have the hardest time. So substitution is going to be kind of a hard way of doing this particular one. I have to distribute this 5 out to that fraction. So my next step, well, let's take it all the way up here. It's going to be 2x minus 5 times negative 3. So that's plus 15 over 2x minus 15 is greater than 10. Remember, you're going to multiply negative 5 times negative 3 here. And then you're also going to multiply negative 5 times positive 3 to get that negative 15. I want to convert 2x into 4x over 2. Now what I did, I just wanted to come up with the common denominator. So I had 2x over 1. I wanted to make that something over 2. So times 2 gave me my 4x over 2. This x goes with my numerator. So that's 19x over 2 on the left side. I'm going to add 15 to both sides. I get 19x over 2 is greater than 25. Now to solve for this, I'm going to multiply both sides by 2. And I have 19x is greater than 50. Divide by 19, and I have x is greater than 50 over 19. So, wow, on that one. To solve for y, make a little room here. Let's solve for y using, I don't think it's going to make much difference here. We'll use 2x minus 5y is greater than 10. No, I can't use that one. Let's use 3x plus 2y is less than 6. So 3x plus 2y is less than 6. What I'm going to have is 3 times 50 over 19 plus 2y is less than 6. Giving me 150 over 19 plus 2y is less than 6. I need to make some more room. You see, this one's getting fun quickly. Alright, now I want to subtract 150 over 19 from both sides. That way I have 2y is less than 6 minus 150 over 19, because these will cancel. If I want to make 6 over 1 into something over 19, I've got to multiply by 19. 19 times 6 gives me 114 over 19. Alright, so we're getting there. 114 over 19 minus 150 over 19 gives me 2y is less than negative 36 over 19. When I divide by 2, or multiply by 1/2, then it'll cut that top number down. So y is less than negative 18 over 19. Now, here's where you run into the problem with substitution if you try to use that technique. Let's look at where we thought the answer was, 3, negative 1. So we thought that it was around 3, negative 1 when we did it by graphing. look at where we're at here. Whoa, where did I go? Okay, 3, -1. I went to the wrong page. I'm going to put question 3, -1. I came up with y of -18/19. That is very near -1. This would have to be -19/19 to equal -1, meaning it was a little less than that. Down here, we have 50 divided by 19. We thought it might have been around 3. We weren't sure. Well, if you do 19 times 3, what you're going to get is 57, not 50. But it was really, really close if you can split something up into 19ths. So let's go back to the graphing method. The reason I did this was to just show you how close we were. 3, -1, although close, was not exact. The exact point where that crosses was indeed 50/19, -18/19. And there was no way you could ever determine that through the graphing method. So that's where the graphing method can be weak. Now, if you're wondering about the less than, greater than symbols, I want to return to the graph again. Notice these are dotted lines. The actual point of 3, -1 that we were approximating using the graphing method does not actually get contained within the solution set. That is going to be less than 3, -1 in 2 different points. So that's the downfall to using these methods with inequalities. You get into some very involved mathematics. If it doesn't work out perfectly, you see where you're at. All right, now, peace of mind, I have not seen this on an actual placement test, but I have seen it on Algebra A tests. So just make sure you have an understanding of the process. This in particular problem you probably won't have to face very often, though. All right, and finally, by elimination. This is somewhat simpler. Remember, with elimination, what you want to do is you want to get either my x's the same or I get my y's the same. If I want to get my x's the same, in other words, which are you going to eliminate, meaning get rid of? Eliminate x's way 1, excuse me, or eliminate y's way 2. Show you how it works. If you want to eliminate x's, I want to make my x's the same. I'm going to do 2 times everything here. I'm going to do 3 times everything here. And I'm going to subtract. That's going to give me 6x plus 4y is less than 12. Remember to do all 3 terms. My second one is going to be 6x minus 15y greater than 30. And I'm going to subtract everything in that bottom line from the top. That way my x's go away. These are gone. I have 4 minus -15, which is 19y. Just put equals. You don't want to even go here. All right, you see everything's wrong. Now 12 minus 30 gives you a -18, and hopefully this looks familiar. When I divide by 19, I get y is somewhere around -18/19. It's obviously not equals. I don't want to even worry about those signs since they differ right here. Now, once I get that, I would just instantly go to way 2. You can sometimes just do that way easier. I can substitute y back in. Let me page up. Let me leave this for a second. When we found y of -18/19, what I can do is substitute that in to solve for an x of 50/19, going through all this mathematics again. But I recommend to now go back to where you started. I'm going to erase some stuff over here. And I want to eliminate my y's. I'm going to do this next. To eliminate my y's, I need to multiply everything to have 10 y's on both. I'm going to do 5 times everything at the top. So my first equation comes in to be 15x plus 10y less than 30. My second equation is going to be 4x minus 10y, and that's greater than 20. I'm going to add these equations together, and the reason is if I add them, these are already gone. So it's up to me which one I choose. So 15x plus 4x is 19. Over here, 30 plus 20, that's 50. I'm just going to convert that to equals. I'm not going to worry about the signs. Again, you don't want to go there. When you cross these out, you get x equals 50 over 19. Now, hopefully you followed that process to where that made pretty decent sense. Especially, I wanted to do this one last, especially as compared to the substitution method. The elimination method just inherently is simpler on some of these more complicated ones. So we got 15 over 19 for x, negative 18 over 19 for y. Let me page up, and you'll see we got the exact same values previously if you forgot what those were. All right, so that is exactly the same as what we received here. I think most people would find this much simpler to do coming from elimination method. Again, Algebra A, you'll do a ton of this. Algebra 1, just try to have some comprehension of the process, and we'll do a couple of days of practice with it. All right, that's it. You have reached the end of it. We talked about graphing all sorts of things. Talked about slope, y-intercept. Talked about horizontal, vertical lines, parallel, perpendicular lines, inequalities, and systems of solutions. Go to, after we get this all finished, go to the website, and I'm sure you have a link to it. If you're in Algebra 1, you have a link to it. Mr. K's mathclass.web.officealive.com. I'll put some worksheets and independent study credit for your process going through this online very soon for you to use here for semester 2. So take advantage of that. And thanks for watching. Hopefully that helped your comprehension of the graphs.